Good day, everyone. My name is Eileen Anbugahod. Today, I am going to share the topic that was assigned to me, which is graduated tool, and we will be focusing on tapes. So let's have first our learning objectives. By the end of this presentation, you will be able to first know the basic functions of a tape measure, convert numbers within the metric system, learn how to read tape measure to determine proper measurements using metric system, and recognize that numbers are often used to describe and compare properties of physical objects. Let's proceed to our motivation. So what can you say about the illustration? Okay, as you can see, there are tapes. What else? Okay, you can also see or notice numbers, right? Which means that today we will be engaging measurements and of course numbers. Before we will recognize the types of tapes, the history, it's very important for us to know the definition of tape or tapes. Because sometimes when we hear the word tape, it could be an adhesive tape, audio tape, or measuring tape. Let's define the tape that you can see on the slide so you will be able to determine what tape I am referring to. So what is tape or tapes? Tapes are used in surveying to take linear measurements. They are available in different lengths and can be made of different materials. So it is mentioned in the slide that it is used in surveying to take linear measurements. Clearly, we are not going to talk or discuss about adhesive and audio tape, but instead tapes that can be used in surveying. Maybe you're wondering where the tape comer came from, who invented it, when it was invented. So now, let's have its history. But first, I have something to share. So, the origin of many tools is lost to history. No one knows who invented the first pliers, hammer, or even the screwdriver. It's hard enough to even find who made the first modern version of many tools. There are a few exceptions, and the tape measure is one of those exceptions. Like the folding rule, the invention of the tape measure is recent enough that we have a good amount of information about it. One of the first documented tape measures arrived on the scene in 1829 and was patented by James Chesterman. This first tape measure was made of steel and was made from the leftover wire that was used for hoop skirts. Which means that James Chesterman patented one of the first tape measures in 1829. So when we say patented, it's copyrighted. So, making it one of the first recognized tape measures, and the original tape measure was constructed of steel and was manufactured from scrap wire left over from hoop skirts. The tape measure underwent further change in 1868 when Alvin J. Fellows, who was from New Haven, Connecticut, filed for a patent in the United States. The Fellows tape measure required some changes to the design of the Chesterman tape measure, so many changes that Fellows was able to argue that he had invented something new rather than just improving on a design. What he did claim was that his improvements, a unique combination of a case, cover plate, click spring, lever and knob, constituted a new invention when the whole is constructed, arranged and fitted for use. They were incremental changes to a device for measuring increments. Which means when Alvin J. Fellows filed for a patent in the United States in 1868, the tape measure underwent yet another transformation. Fellows was able to demonstrate that he had invented something new because Fellows tape measure required significant adjustments to the design of the Chesterman tape measure. Let's have the types of tapes. First, we have linen tape. Also known as cloth tape, is a varnish strip made of closely woven linen. The width of the strip is about 12 to 16 mm. It is available in different lengths such as 10 m, 20 m, 30 m, and 50 m. Both ends of the linen tapes are provided with metallic handles, and the whole tape is wound in leather or metal case. Linen tapes are light in weight and easy to handle. These tapes may shrink when exposed to water and elongate when pulled. The second one is the woven metallic tape. It is an improved version of linen tape. Brass or copper made are used as reinforcement for the linen materials. Hence, it is more durable than normal linen tape. A brass ring is provided at the end of the tape, which is included in the length of the tape. These tapes are available in different lengths of 2 m, 10 m, 15 m, 20 m, 30 m, and 50 m. The third one is the synthetic tape. Synthetic tapes are made of glass fibers coated with PVC. These are light in weight and flexible. They are available in lengths of 5 m, 10 m, 20 m, 30 m, and 50 m. Synthetic tapes may stretch when subject to tension. Hence, these are not suitable for accurate surveying works. However, synthetic tapes are recommended in place of steel tapes where it is essential to take measurements in the vicinity of electric fences and railway lines and etc. The fourth one is the steel tape or push-pull rule. A steel tape is made of steel or stainless steel. It consists of a steel strip of 6 mm to 16 mm wide. It is available in lengths of 1 m, 5 m, 8 m, 10 m, 20 m, 30 m, and 50 m. Meters, decimeters, and centimeters are graduated in the steel strip. Steel tape generally came up with a metal case with automatic winding device. The tape is withdrawn from the case by using a hand during measuring, and it is rewound into the case by just pressing button provided on the case. The last one is the invert tape. Invert tapes are made of an alloy which consists of 36% of nickel and 64% of steel. Invert tape contains a 6 mm wide strip and is available in different lengths of 30 m, 50 m, and 100 m. The coefficient of thermal expansion of invert alloy is very low. It is not affected by changes in temperature. Hence, these tapes are used for high-precision works in surveying such as baseline measurement, triangulation survey, and etc. For the 5 types of tapes, we will be using steel tape. So here are the parts of steel tape. Number 1, we have blade or tape. The tape, also known as the blade, is what you use to get your measurement. Most tapes feature imperial units or inches on the top row and metric units or centimeters on the bottom. Number 2 is the spring and stop. The action that pulls the blade back into the case when you release the thumb lock is the spring and stop. It is what makes it so that on a purely mechanical tool, you don't have to push the blade back in manually. Number 3 is the case. The case is like the house for the tape where it lives all nice and cozy. The most durable models are made from metal while plastics is more affordable. Number 4 is the thumb lock. You can stop your tape measure from automatically retracting by pressing the thumb lock down. Push it back up when it's time to put the tape measure away. Number 5 is belt loop. Tape measures are pretty bulky things to carry around. They're shaped vaguely like a square, and if you are working with any kind of length, they might be big and heavy. Getting one around might be a chore, especially if you have several tools to carry. Most tool bags have specific places for tape measures, but most tape measures have loops so you can connect them to your belt. Number 6 is hook. At the forward lip of the blade is a hook that allows you to slip it over the side of something you are measuring and pull it out as you go. This prevents you from having to feed it out as you go and makes it easier to measure things with relatively large distances. Later on, we will be using metric system in measuring. So, why use metrics? Scientists use the metric system when making observations and taking measurements. The metric system is a form of measurement that scientists around the world use. This form of measurement is also known as the International System of Units or SI. This measurement system allows scientists to be as precise as possible when performing lab experiments. In science, everything must be exact. So not all countries is using metric system. So countries that have not officially adopted the metric system are Myanmar, Liberia, and the United States. What is metric system? The metric system is a system of measurement that uses the meter, liter, and gram as base units of length, which is distance, capacity, which is volume, and weight, which is mass, respectively. To measure smaller or larger quantities, we use units derived from the metric units. So how to read steel tape using metric system? Since we're talking about the metric system, as you can see in the illustration, this is the bottom part of the tape which we will be using in metric measurement. So this is the centimeter. Every number on the bottom represents a centimeter. In every distance 1, 2, 3, 4, that is 1 cm. The small lines here are millimeter. Every one line here is 1 mm. And that 1 cm is equivalent to 10 mm. For example, we are measuring this object. If we will measure this, it falls on 4. You will read it as 4 centimeters. Again, in every distance from 0 to 1, from 1 to 2, that is 1 cm. And in measuring this object, we started from 0 to 1 and it falls on 4. So the length of this object is 4 centimeter. Now let's have our example number 2. For example, this object or this harness stick that you are measuring pass over a little here. It exceeded 4 small lines. It will be read as 1, 2, 3, 4.4 centimeters. Let's proceed to our example number 1 in millimeter. If we are to measure this brown comb, it will be read as 33 millimeters. Why? Because, as I've mentioned earlier, that in 1 cm, it is equivalent to 10 mm. And if we find the length of this object, you will just add all the 10 until here in 30. And since it exceeded through to 3 small lines, so 30 plus 3, it is equal to 33 millimeters. Let's have another example of mm. So the length of the ball pen is 35 millimeter because if we add again all the 10 until 30 plus 5 it is 35 millimeters. Now, let's have a try. What is the length of the key in centimeter? Okay, I'll give you 1 minute in finding its length. So time's up. If we are going to find the length of the key in centimeter, it will be read as 1, 2, and it exceeded 5 small lines, so its length is 2.5 centimeter. Number 2, how many centimeters is the hanger? I'll give you another 1 minute to answer. Time's up. So 1, 2, 3. So the hanger is 3 centimeters. Number 3. How many centimeter is the ball pen? Another 1 minute to answer. Time's up. So, let's start. 1, 2, 3, 4, and it exceeded to 3.5 small lines. In 1 centimeter, it is equivalent to 10 millimeters. So, if we are going to multiply 4 times 10, it is equal to 40 millimeters if we are going to read it in millimeters. And it exceeded to 3.5, so 40 plus 3.5 is equal to 43.5. And if we are going to convert 43.5 into centimeter, in converting millimeters to centimeters, we are going to divide the number of mm by 10 to get the number of cm. So, the number of mm is 43.5 divided by 10, it is equal to 4.35. So, the ball pen is 4.35 centimeters. Number 4. What is the length of the candle in millimeter? I'll give you 1 minute to answer. Time's up. So, in finding the length of the candle in millimeter, we are going to add all the 10 to 40 until 40. So, 10, 20, 30, 40. And it exceeded to 5 small lines, so 40 plus 5 is equal to 45. So, the length of the candle is 45 millimeters. Number 5. Find the length of the pencil to the nearest millimeter. I'll give you another 1 minute to answer. Time's up. As you notice, we didn't start from 0. We measure the pencil at the middle. So it is possible to start measuring in the middle if ever the tape is broken and you couldn't start from 0. So you can or we can measure an object in the middle. So just for example, this pencil, it started from 30 and it falls on 60. And since we are finding the length of the pencil to the nearest millimeter, we will start or we will add all the 10 from 30 to 60. So 10, 20, 30. So the pencil is 30 millimeters. Number 6. How many millimeter is the book? I'll give you 1 minute to answer. Time's up. So, we're going to add all the 10. So, 10, 20, and as you notice, it didn't falls to 30. So we're going to count all the small lines. So 10, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29.5 as it didn't reach to the or it didn't falls to 30. So it will be read as 29.5 millimeters.
We can measure how long things are, or how tall, or how far apart they are. The most common measurements are millimeters, centimeters, meters, and kilometers. How big is a millimeter? No, it's not the size of a banana. It's the size of the little metal part of this pin. Each line marks 1 millimeter. The banana is almost 200 millimeters long. Let's measure some other things. The diameter of this cup is 85 millimeters. The mm means millimeters. The back of this kitchen chair is about 1,000 millimeters. Centimeters. 1 centimeter is 10 millimeters. The cm means centimeters. Example: 8 centimeters is 80 millimeters. The banana is about 20 centimeters. And the chair is about 100 centimeters. The meter is the basic
That's
measurement.
all, and thank you.